otherwise, I'm very excited to get started. Andrew, I'm going to pass it to you first if you want to quickly introduce yourself before I hand it over to Nanditha.
Hi, everyone. I'm Andrew. I was the first software engineer at Causal. For those of you who don't know what Causal is, it's basically just a better way to work with numbers. So if you want to make a financial plan for your business, if you want to decide ROI on a new project, model out cloud spend for the next couple of years, you should check out Causal. And I'd be remiss if I didn't mention that we're hiring. So you should also check us out if you're interested in the new role.
Awesome. Thank you, Andrew. Nanditha, if you want to introduce yourself, and then feel free to kick it off as well.
Awesome. Cool. Thanks, Dorothy. Yeah. So hi, everyone. My name is Nanditha. I'm one of the solutions engineers here at Sentry. So a big part of my role is, not only helping out with these webinars, but helping with any sort of technical issues that come up with our customers, a lot of demos, and things like that. So yeah, for the portion of this webinar, I'm going to be focusing on distributed tracing, how Sentry approaches the concept, and then from there, kind of diving into some best practices around performance. We did see that there were a couple of questions that came through the pipeline already. So I'm going to try and weave those as well into the conversation as much as possible. But yeah, excited to be here and talk to you guys about Sentry's performance monitoring tool. Awesome. So I'm just going to kick things off. So a big part of Sentry's whole time to resolution solution is part of this whole See, Solve, Learn initiative. You may have seen this before if you've worked with any of our CSMs or our SEs. So a big part of what we want to do is make sure that you have the appropriate insight into the context that Sentry's surfacing for you, right? So having visibility into the various different platforms that you have Sentry integrated with, being able to solve issues as fast as possible, right? So being able to dive into those core issues to make sure that overall your application is healthy, and then learn, right? The last part is really making sure that you have the appropriate insights for any future developments in your product, right? So that's kind of covering our Discover and Dashboards feature, which is something that I believe Andrew's going to talk through, and I can also kind of touch on as we go through this. Great. So performance as a whole, so Sentry within the last year or so has been investing a lot of our resources into our performance monitoring tool. Really simple and easy to get up and running. It's with the same SDK. And the idea here is you're able to track down those performance-based issues, similar to how Sentry has various different features to make sure developers like you guys are able to pinpoint those exact issues that are causing any sort of error in your application. Similarly, from the performance standpoint, taking a look at latency, aptX throughput, failure rate, as well as other metrics that we'll definitely touch on as we go through this. Awesome. So at a high level, I just want to provide some context around the sort of vitals that we surface. Again, as we go through the demo, I will dive into further detail into what are these metrics, what are some best practices, what have we seen other developers out there find helpful. But at a high level, right out of the box, you do get Google's Web Vitals. So that encompasses first contentful paint, largest contentful paint, as well as first input delay, as well as cumulative layout shift. In terms of mobile and the conversation of mobile, so whether that's React Native, iOS, Android, we capture metrics such as cold start, warm start, slow frames, frozen frames. And then from the backend perspective, right? So you have context into throughput, failure rate, aptX, duration, which can be reflected off of P75 in this case, or P95, or whichever other thresholds that your team is interested in seeing. But yes, just to kind of summarize here, right, we're going to kind of dive through this as we go into the product. But just kind of to level set, these are the three areas that we focus on, and we'll take a look at through the demo. Awesome. So just to kind of level set here, there's three parts of this conversation. So there's the trace, transaction, as well as span. So this is kind of where we'll really level set on how does Sentry approach distributed tracing from your front-end application to the back-end application. So just to kind of provide some context here, as we can see that lowest visual, which is our trace, this is essentially where you would This is the operation where you as a developer are interested in instrumenting observability around. The example that we like to give generally is a page load kicked off by your browser application, right? So that's kind of in this context, but depending on your use case, this can of course vary. You can also think of in the mobile context, such as a sign-in or loading a view in your application, right? When we think of a transaction, right, so the next visual here, a trace can consist of multiple transactions. Usually they refer to calls to services where you've instrumented Sentry's performance product. This could be anything from being kicked off by a browser, right, from your page load. So in this case, if we were to dive into one level deeper, we have our span, and we can think of transactions as trees of spans, right? So a transaction can have multiple different spans. This is the smallest unit of work, in this case, that the browser is doing to load the page. You can think of things like React requesting resources or React component lifecycle events. We also have higher order functions available to capture these React component lifecycle events. To add a little bit more color on spans, these can represent calls to external services. Generally, when we think of a call to an external service, this represents a new transaction within our trace. So in this case, right, we can see this flow where the front end is making some sort of call to our backend application, which is then making some sort of second request to an external service, so this database server. Just to provide some color right up front, Sentry does use head-based sampling. So when we talk about sampling in general or capturing the appropriate amount of transactions, Sentry will capture a transaction all the way through your tech stack. So from your front end all the way to your backend application. Yeah, so that's kind of it in terms of just providing that high level. So from here, Dorothy, I think I can probably start sharing my screen. Awesome. Cool. So great. So just to provide a little bit of context here. So when you get up and running with Sentry's performance product, it's pretty straightforward. Again, this can slightly vary depending on, in terms of the conversation around auto instrumentation, custom instrumentation, this can vary depending on the SDK, of course. In this case, we're going to just briefly talk about what this would look like for JavaScript. So in regards to auto instrumentation, you do get page load as well as navigation out of the box. To get up and running, it's pretty straightforward. You need the appropriate integration package, of course, your DSN key, which I'm assuming most of us are familiar with at this point, right? So this is telling Sentry where do you want to send your not only error events, but transaction events to. So which project that you want your data to be shipped up to, right? You have your browser tracing, provide the tracing origins as well as the traces sample rate. So traces sample rate is of course a required field. So this is telling Sentry how many or how exactly do you want to sample your transactions? Do you want to ship up 100%? So one being 100%, but of course, as best practice, we generally suggest starting off with a lower number and working your way up. But again, this can definitely vary depending on your application. Quickly touching on custom instrumentation. So again, for most, if not all of the various different platforms that we do support, you do have the ability to set up custom instrumentation. Again, this can vary depending on your application and the platform you're working off of, but just to provide some color around what we're going to be seeing in this webinar and part of the demo is a checkout flow, right? So I have a sample application, right? So let's say I'm interested in seeing, okay, what does it look like when a user essentially goes through the flow of trying to purchase an item or working through my web application. So this is essentially what it would look like, being able to start a transaction as well as capture span level details, right? And the idea here is at the end, once you've instrumented the appropriate information, right? So like taking a look at the span level details, any tag values you want associated with an individual transaction, essentially all of the metadata you would store here. You could then finish up the span, finish up the transaction, ship it up to, which will then, once the transaction's captured, be shipped up to Sentry. Awesome. I'm just gonna hide this Meeting controls. Awesome. So diving into the demo itself, some of you have probably seen this application before. Essentially what we use to showcase what Sentry's error monitoring and performance monitoring tool could be used and kind of showcase those best practices. So just to quickly empty cache, hard reload. So within this web application, it's just a sample application to, again, showcase performance. So my front end, which is in React, has Sentry's performance product instrumented in it, as well as my backend application, which is Flask. Again, we'll take a look at this as we go into Sentry, but both my front end and backend application do have the performance product set up. So just really quickly going into the network tab. So we're going to be taking a look at two main transactions. The first one is going to be around latency, which we can of course see here right now, right? So we can see that my application's taking a bit of time to load, which is the expected behavior, right? For the purposes of this demo. And the second transaction that we're going to be taking a look at is in regards to custom instrumentation, right? So as a user, I go into my store, my plant store, attempt to purchase a couple of items, proceed to checkout, submit, cool. So in this case, we run into some sort of trouble. This is what is expected. So not only is Sentry going to capture this error, but any sort of transaction that may have come up in regards to this issue. So from here, we would essentially dive into the performance product. So just to kind of level set here, right, for the folks that have not seen Sentry's performance product, we are making changes within the next year. We're trying to move our product into a more customizable form for developers. So making sure that you as a developer, regardless of the sort of application that you're working on, you're able to see the most valuable metrics for your team, right? So right up front, you have context into quite a bit of information. You can also filter based off of, again, the sort of application you're interested in or that you're working off of, right? So front end, back end, mobile, web vitals, right? So tied to front end as well. But in terms of this first page, we have a couple of metrics here, right? So we have user misery, transactions per minute, as well as failure rate. So in regards to user misery, to provide some context here, this is a user-weighted performance metric to assess the magnitude of your application's performance. Apart from that, you also have AppDex. I believe we can filter through that here as well. Yeah, so in terms of AppDex, it is an industry standard metric used to track and measure user satisfaction based on your application's response time. In regards to both user misery as well as AppDex, you can actually configure these, again, depending on your application, the volume, the sort of users for your application. You can configure these metrics and thresholds from the project settings. But beyond that, right, you also have insight into failure rate, transactions per minute, again, kind of touching on Sentry's value add of being able to customize the sort of metrics valuable to you. So in this case, maybe I'm interested in seeing duration based off of P75, right? I can surface that sort of information. And this can, of course, be customized based off of the user, based off of the developer. So each developer that works off of Sentry, you have the ability to surface those specific metrics that are valuable to you. And below that, we have a couple more data points that are surfaced. So we have most regressed, most improved. So in this case, Sentry is surfacing to you right up front. Okay, what are those transactions that have had a negative impact or have worsened in any way? Or we can see on the flip side, most improved. So what are those transactions that we're seeing basically an improvement in the time? So you can see that as well as most related issues. So this one definitely, I've noticed a couple of developers that I've worked with find helpful, just because in the conversation of distributed tracing, you have context not only into the specific transactions, but have the connection of what are those issues that are related to the transactions that have come up. So what are the transactions that have the highest number of issues in relation to the transactions that have come up from my application? So without having to go through every single or some of the top transactions here, to understand, was there an impact on the error side as well? Sentry is surfacing to me, okay, what are those transactions? I can from here dive into the issue as well to then see the correlation between my transaction and my error event. So diving into those two transactions that I had mentioned, so the one tied to latency and the second one tied to my checkout. So the first one that we're going to be taking a look at is tied to latency. So as you can see here, Sentry surfaces quite a bit of information. You may also notice that we have a couple of new features, which I'll be talking about as well from this page. But just starting off at the top, right, you have the ability to, of course, search for specific data points that you're interested in seeing, right? So in any case, right, maybe we're interested in seeing what is the impact on browser or specifically a Chrome browser, right? So since we that's kind of where we're working off of from our application, we can see the data reflective of the tag values that are surfaced here, right? So Sentry really wants to make sure that you as a developer, you're only seeing the information or you're seeing the information that's valuable to you and your team. So going down here, we also have context into the slow transactions, right? So we'll come back to this as we work through this. We also have a recently released feature called suspect spans. Some of you may have already taken a look at this, but really the idea here is we're surfacing what are those spans that have some sort of impact to latency in this case, right? Similarly, suspect tags, what are those tag values that are contributing to latency? So the value add for both of these is that you're able to immediately see what does the impact look like, where in my application I should be diving into as a developer, right? Again, data points that are really there to make sure that you're able to resolve these performance-based issues faster. And below here, we also have context into those related issues, right? So what are those issues that may have contributed to latency as well? Insight into the tag values, right? So this sort of heat map that's giving me a breakdown of, so in this case, what was the backend type, right? So I can see that the impact was Express, Flask, as well as Spring Boot. I have context into the browser impact, as well as any sort of custom data points that I'm interested in seeing, right? So based off of your team's business logic, you can, of course, ship up tag values that are relevant to your team. And at the top here, right, you have, so we kind of briefly talked about these data points previously, but you have context into the misery, aptX, failure rate, throughput at a more granular level, right? So in regards to this specific transaction. So diving in further, right? So just to showcase what this would look like. So within one of my slower transactions, I can see, okay, this is in regards to page load. I can see quite a bit of span level detail, and immediately I can kind of pinpoint, right? Okay, where exactly should I be taking a look at? So this is the span that I want to open up, and I can see immediately that there is a child transaction associated with this this front end transaction, right? So taking a step back, this ties to the concept of distributed tracing. So not only am I seeing, okay, there was an issue coming from my front end application, it looks like there was also something that was captured from my Flask backend. So, right, so this is tied to my Python project. So from here, I can dive into the backend transaction, right? So I can see here, there's a couple of long spans, but just to, again, taking a step back, just to summarize kind of what we've seen, right? We've gone from our front end application, noticed that there was an issue that was actually stemmed from our backend application, right? And then from here, I get further insight into where exactly in the application should I be diving into, right? So it looks like some sort of issue before these select queries are run, right? So I'm not only able to see, okay, where in the application, but not only which part of the application, but where in the application I should be taking a look at to solve latency in this case. So the second issue that I wanted to surface, right, was in regards to custom instrumentation, right? So let's remove these filters up here. So what we would want to be looking at is the checkout transaction. Sorry, let's go back. front end should be one of, yeah, let's go into this one. So essentially kind of showcasing, right? So I don't believe it's this one. Oh, here, perfect. So if we go into this transaction, right? So just to level set, this was the second transaction we were interested in seeing. So this was tied to, as a user, we went in, attempted to check out a couple of items. And from here, we can dive into the transaction itself, right? So we can see immediately that not only was there a transaction captured, but there was an error associated with this transaction, right? So not only can I see this from the event details page, but I can also view this from my full trace, right? So we had 3 different layers within the conversation of distributed tracing. We had our trace, transaction, and span. So this is our transaction view, but if we wanted to take a look at this from a high level view, and I believe Andrew's also going to be talking about this as well, but we have context into the different layers within our trace, right? So not only did we see that there was a front end transaction, but there's also an error occurred, that there was an error that happened within this transaction. Similarly, within my backend application, we can see there was a transaction as well as an error that was captured, right? And from the trace view, I can take a look into the issue itself, right? So we can see that it's my Spring Boot project. And then from here, I can take a further deep dive into the issue itself. One last thing here before wrapping it up on my side. Let's say as a developer, you wanted to approach this from the issues page, right? If you primarily work off of taking a look at the errors that come up before taking a look at performance, you can always take a look at this view full trace. Again, if you have distributed tracing set up, you'll have this option where you can dive into that, again, the trace view, right? Giving us a breakdown of what was the impact throughout your tech stack, as well as what was the total duration, how many transactions, as well as how many errors that were captured within this individual trace. And one last thing that I want to touch on, right? So with all of this data that Sentry's collecting, you can definitely lean on our dashboards feature. If you have not gotten a chance to take a look at this yet, Discover as well as dashboards are 2 ways that Sentry allows you to visualize your data, making sure that you're able to surface the appropriate patterns, trends, any sort of anomalies in your application health. We did recently release some of these generic dashboards so that folks that are newer to Sentry have an idea of what sort of metrics you can surface and have insight into. So just to kind of quickly showcase, so for example, for front end, you may be interested in seeing, okay, what are some of the slow page navigations, or maybe some of the slower transactions, right? Or you're interested in capturing data based off of LCP or first input delay, and what does that impact look like across the world? Similarly, you may want to see, okay, what are some of the issues assigned to you as an individual developer or your team? Again, all of this information can be reflected based off of the date and time range that you're interested in seeing. A lot of folks are interested in last 30 days. So that's looking at what does the data look like within the last billing cycle, right? Or maybe you're interested in seeing within the last hour, some more real-time information. So as data is being collected, you have context into how is this affecting my application, or what are the trends that we're noticing, and where in the application should we be diving into. Similarly, we have the same previews for backend as well as mobile as well. But I'm going to take a quick pause here, and I think this may be a good time to transition over to Andrew, who will kind of dive into their specific use case, how they're using Sentry's performance product, and close things out with our dashboards feature.
All right, thank you. Let me share my screen real quick. Share the right window. All right, great. Can we all see a window with Causal open?
Yes.
Awesome. All right. So I'll start by talking about how we got started actually using Sentry for performance monitoring. Just to give some context before that, this is what Causal is. As I mentioned, it's a way for working with numbers. So we're in a causal model right here. And one thing that's quite important for later is that on the actual backend, the way that we implement the like causal model evaluation is like one of our most important. It's like one of our most critical pathways. So that's taking a model which has a bunch of formulas and turning it into the actual numbers that you see here. So when we started with Sentry, we added it just to keep track of errors. Before this, we didn't have anything for performance monitoring. And since we had it for errors anyway, it was quite easy to just add the performance monitoring as well. And so when we got started, we started with just a lot of automatic instrumentation. So you just saw a bunch of that integration with like Postgres, integration with Express, all that came for free. As we saw that it was useful to have this automatic instrumentation and we wanted more information, we started to add more custom instrumentation. So today we have both automatic and custom instrumentation across 3 different services. Our front end, which is here in React, our backend, which is written in Express in TypeScript, and then our evaluation service, which is written in Golang. So as far as moving from like automatic instrumentation to manual instrumentation, we wanted more insight, and it was quite useful in actually solving real performance problems we saw in the app. So let me show an example right here. So this is actually a distributed trace. You can see that we have the evaluation request on the front end. That's sent to our evaluation service in Go, which then will send a request to our Express backend. And I'm going to go ahead and jump into this transaction for our Express backend, so you can see an example of what type of data we have. So first of all, you can see that the Express integration gives us a look at all of our middleware, so we can see if anything is taking longer than expected. We can see it all looks pretty good here. And then we get into some custom instrumentation. So yeah, here we have some permission system stuff. I'll talk about that later. And then we have the actual business logic for taking a user's model, analyzing its dependencies, and fetching these things from the database, so on and so forth. Again, tons of automatic instrumentation here for Postgres, which is quite helpful in understanding if any queries are slow. So in one case recently, we had a problem where a certain user's model was taking forever to evaluate. And we couldn't really copy it locally easily, so we had to figure out what was going on. We were able to look on Sentry, see the slow transaction, and realize like which exact phase of the kind of dependency graph generation was causing a problem. You can see here, this adding the default scenario is taking a whole second when everything else is taking on the order of like 10 to 100 milliseconds. So this is like quite useful in understanding these problems, which are hard to replicate locally. So that's a good example of one performance issue. This is on the back end. I want to look at another example of how we can use Sentry on the front end. So here, if I go back to Causal, we have this formula editor here. This is quite a simple one. It's just 40,000, but in other formulas, we might have much more complex values, things like this, where we're adding together 2 different revenue variables. And so it's quite important that this editing experience is fast for users. And so what we did is we added a lot of custom instrumentation, as well as automatic instrumentation around the React components, in order to understand when a user opens up an editor, what's fast and what's slow. And so you can see here that we were able to identify that there's a problem with a certain lifecycle method that's getting called on these editors. And we've been able to investigate our Redux store performance more because Sentry pointed us to this issue. So that's a bit about how we use our both automatic and custom instrumentation and some performance issues that we actually solved with Sentry. But beyond just investigating single events, Sentry is quite useful for us in getting a general overview of how our app is performing as well, all the way from development through QA and to production. So I'll show a couple of dashboards that we have set up that can give a sense of this. So this one is a dashboard giving performance of our permission system. For context, we recently worked on some product updates that required totally rethinking how we thought about permissions in Causal. And so we wrote a whole new permission system, and we wanted to get a sense of how this is performing. This permission system is used in almost every single request to the Causal backend, so it's quite important that it performs well. And it's quite important that we know if it starts to be slow because it's going to bottleneck every single request. So you can see here that we have a bunch of charts set up with P50s, which is the 50th percentile of the transaction duration, and then P95, the 95th percentile for these different what are called permission providers. And so based on this dashboard, we can get a sense, by checking it immediately if a certain provider is being slower than expected, and we can act on that quickly. And one more dashboard that I'll show, a custom dashboard that we set up to look at the front-end performance. So the previous dashboard was really about one specific part of the backend. This dashboard here is more about giving a general sense of how the front end is performing. If you've ever worked on any front end application, you've probably had the problem, like our users are saying something is slow. We don't really know when that's happening. We don't know if everybody's reporting it. We want to get some visibility into that. And that's what this dashboard is providing. So this top visualization here, we set it up so that it's showing the proportion of all transactions in Sentry that are taking an okay amount of time versus are slow versus are terribly slow. So you can see this orange at the top here is the percent of transactions that are terribly slow. The pink in the middle is the ones that are slow, so they're taking between 100 and 1,000 milliseconds. And then the purple down here is the things that are acceptable. They're below 100 milliseconds. And so this allows us to know pretty much immediately if we release some change and it's causing our entire app to slow down unexpectedly without any users necessarily needing to report it to us. We can just get a sense if the proportion of terrible transactions is increasing, and we can act on that. To show a couple more things that we have, this is quite a useful built-in visualization. It shows which tasks are typically the slowest. So you can see it's picking the P75, the 75th percentile of these transaction durations. And so we can get a sense for, what are the things that we need to focus our performance efforts on first. This just breaks down the previous chart by actual transaction. And then finally, at the bottom, we have a couple of more specific charts. One that gives us a sense of how Redux performs. We use Redux on our front end, and we use it for everything. So the performance there is quite important. And then finally, looking at one key transaction, which is this pre-processed data computation, which happens all the time on the front end. And if this is slow, everything will be slow. So we see the proportion of requests that are taking greater than 300 milliseconds, which is the threshold that we decided will appear to a user to be slow or clunky. So that's all I have. Just to recap, we started off with Sentry because we were using the Era product and the performance was free. We quickly realized it was super useful and added a lot of custom instrumentation. As we've developed new features and as we've updated old features, we've added this custom instrumentation and got lots of value in both understanding specific performance problems and getting a general sense of how our app is performing. And we can use these dashboards to make sure that we're always up to date on how performance is looking across the front end, the back end, and our evaluation service.
Awesome. Thank you, Andrew. That was super helpful to see, and always nice to see how easy things are to set up for sure. So we will now transition. We have a few questions. I know we've been responding to them live, and then we'll answer them here as well. Nanditha, I think this question might be for you. It kind of popped up during the demo that you were doing a little bit earlier. How did you connect the front end with the back end to be on the same transaction? And then a follow-up question is similar to that, but if you have multiple front ends, for example, different projects or clients, how did you do that?
Yeah, that's definitely that's a good question. So in terms of how Sentry approaches connecting the front end to the back end, so distributed tracing relies on passing the headers from one call to the next. So that's essentially how we approach it. So Sentry also does use head-based sampling, as I mentioned. So when a transaction is sampled in the front end, it's guaranteed to be sampled from service to service, right? So in that case, again, I may have not mentioned this previously, but Sentry does need to be instrumented within each layer. So both from the front end perspective, back end, or any external services, for Sentry to be able to capture as well as pass the headers from one call to the next, you will need to have Sentry instrumented at each point.
Awesome, thank you. Next question, is there any recommendation or best practices to set up a transaction name?
Yeah, I think I answered that question. I sent over the documentation for that one. Yeah, so if you go into Sentry Docs, there is a set transaction name, page that essentially kind of walks through what's the best way to approach this. So if it helps, I can maybe throw it into the chat here.
Awesome. Thank you. I will make sure that gets out in a follow-up as well. Always helpful to send docs links for sure. So perfect. And then I think you covered this a little bit, but maybe you can go into a little bit more detail on if you can, Nanditha, explain the terminology such as P50, P75, AppDex, TPM, etc., and how to make sense of them in the graphs that you showed.
Yeah, I think that's definitely a good question. So it's going to be hard to answer just because it does vary kind of depending on, what's valuable to the team. Yeah, so I would say, AppDex as well as user misery are really tied to, kind of the satisfactory and response time. You're able to, the kind of value add Sentry's bringing to these metrics is that you're able to toggle as well as really customize these settings depending on what that satisfactory looks like to you guys or for your product and what response time looks like. Similarly, right, so when we talk about P75, this indicates the duration that 75% of transactions are faster than some specific value. Similarly with P95, P90, it's looking at, or it's indicating the duration that 95% of transactions are faster than some set value. When we look at failure rate, this is the percentage of recorded transactions that have had a known or unsuccessful status, right? And I think one thing that Andrew touched on, which was valuable, is showcasing pulling all of these various different metrics with the dashboards, right? So the best way beyond just relying on the performance product is relying on our dashboards feature to aggregate all of this information to notice the trends, to understand how to best customize these values or take a look at these values depending on your application.
Awesome, thank you. Next question, I think also for you, Andrew, feel free to chime in too if any of these are relevant. Are there any best practices to deal with front-end service errors? Can we deal with them exactly like we do in the back end, or is it better to customize specifically to each stack?
I would say this could probably, I don't know if Andrew has maybe some insight on his experience, but this generally I would suggest it would probably have to be customizing based off of each stack. But let's follow up on this. I can get some more information on what engineering would have to say, and then we can provide that as a follow-up.
Perfect. We'll definitely circle back with you on that one. And then we kind of another similar best practices question. We have multiple front-end projects which use a single back-end project. How can we set or how can we best bind or trace events in our back-end to the instrumentation of the user's experience in the front end, which led to an issue?
Yeah, so that's kind of similar, I think, to the question that came up previously. So in the example that we walked through as well, we did have a single front end. I mentioned Flask was the backend, but there were a couple of other backends that it was tied to. So in terms of having a single front end and multiple backend services, it's a similar process of setting up Sentry from your front end application to your backend application, and essentially with distributed tracing enabled across the board. So from your various different backend applications and your front end application, Sentry will pass the header from one service to the other.
Awesome. Thank you. Next question. So our front end and middleware are all fully instrumented on different Sentry products. Do we have any documentation on how to define or add a header and which header to our front middleware requests so that they are all traced together?
Oh,
Yeah.
Oh, sorry.
No, sorry, Andrew, go for it. Yeah.
Yeah, sure. I thought I'd take this because I spent a bunch of time setting this up, and I sent a link to the pages in the docs, which was how I learned how to set it up. I think it should hopefully answer all your questions.
That was great. I just reshared it as well. Okay, awesome. And then I think this was already answered, but in case there's any other resources to provide, do we have a demo Sentry project that has data on the performance metrics and transactions to be viewed for free? I think I saw one previously, would be great to take a look at. And we do have a sandbox. I think that would be the best place to do it. But Nanditha, is there any other resources you'd recommend?
Yeah, Sandbox definitely looks like someone already threw that into the Q&A, which is great. But yeah, Sandbox is definitely the best way to check it out.
Okay, perfect. Awesome. I think those are all the questions that we could get to. I know there's a couple follow-ups we need to do as well, after which we will reach out separately. But I think we can hopefully give people a little bit of time back. I did really want to thank Nanditha and Andrew for taking the time to just share their story here and how they use performance. Hopefully this is helpful to people, but you can always reach out if you have any questions. And just as a reminder, this is recorded, so we will share this out as quickly as possible, hopefully within the next 24 hours. And then if you can do me a favor, those of you that are still here and joined in, just answer the quick survey at the end. We greatly appreciate any feedback on this workshop so we can continue making these helpful for everyone. Awesome. Well, thank you so much, everyone, for your time, and hopefully we'll see you at the next workshop. Thanks, everyone.
Awesome. Thanks, Dorothy. Thanks, Andrew. Bye.